Now the next thing what we have to discuss is combination of resistances. Okay, when there are resistors connected in series, so we can call it as a series combination. And how does it look like? Let me show you in the diagram. So series combination of resistor will look like this. I am taking 3 resistors just for better understanding. It can be any number of resistors, but if they are connected one after the other in a circuit, then it will be treated as a series combination. Okay, so there is a circuit in which potential difference is V, current is I, and the resistors are R1, R2, and R3. They are connected in series, as you can see. Now, if they are connected in series, so I can say that the current going in each of the resistor will be same. Okay, but since we have a formula V is equal to IR, and it entirely depends on I and R, I being the same in all the resistors, you can see that they have individual resistances. Their resistance value is different. So that's why there will be different voltage values across each one of them. And that is what we have learned earlier, that if I want to find voltage across any of the circuit element, then I have to apply voltmeter parallel to that element. So there will be 3 voltmeters which we have to apply to measure these V1, V2, and V3. And they will be applied in parallel, as you can see in the diagram. Okay. So till here, we have just defined a circuit, a series combination, and across all 3 of them, we have applied voltmeters. So the first reading of the voltmeter is V1, and that will be equal to IR1. The second reading will be V2, that is IR2, while the third reading, V3, will be IR3. Now we know that this V1, V2, V3 is what? It is a split of this potential difference supplied by battery. At the end, V1, V2, V3 are supplied by battery only. So I can sum it up as that this V is equal to V1 plus V2 plus V3. Okay, V is the net potential difference across the circuit. So according to Ohm's law, I can replace this V with IR. So what is I? I is the net current in the circuit, and R is the net resistance in the circuit. When we are doing series combination, so for this, I can say that equivalent resistance will be how much? That we are going to see, okay, that we are going to find. So that equivalent resistance for all 3 of them, if I want to replace and put a single resistance, then that value we are going to get from here. If I replace V is equal to IR, V1 will be replaced by IR1, V2 by IR2, and V3 by IR3. It is visible that on both the sides we have I. If I divide both the sides by I, then this I will get cancelled, and I will be left with R is equal to R1 plus R2 plus R3. So what is the final conclusion? That if they are combined in series, it will be sum of all individual resistances.